down with TPP.
Okay. Oh, wow. How do you know all this stuff?
So, welcome back to Obama. Give yourself a hand. Yes, sir. Woo! Woo! Oh, the presidential song was like this.
That's it. That's it. That's the
Do
one.
it. Obama is here.
You should be in a choir.
Yeah.
I think that new job for him.
New job, yeah.
He started an acapella group.
Senator, president,
Acapella.
math teacher, acapella.
World renowned acapella.
Yeah, we're over now. Today we're going to be doing inverse trig functions. Perhaps you've seen it before. I'm going to give you a brief reminder, and it's going to be fun. I think you'll like this. Easily, stay with it. All right. When you take sine of what types of things? Angles, correct. Put that down. You take sine of angles. Angles. And that results in what types of things? Almost. When you say sine is
Sides.
what about their sides? What do you do with the sides?
Measurement. Yeah, that.
Like when you say sine equals what over what?
Sine.
Opposite
over hypotenuse.
Right, so these are sides, right? Opposite and hypotenuse.
Yeah.
So you're comparing sides in a ratio. Put that down. Okay, it's a ratio of sides. You take sine of angles, cosine of angles, tangent of angles, and it turns into a ratio of sides. Flip that script!
Oh my god.
Sine of ratio.
Oh my
What?
lord.
How do you call
Sine.
this?
Inverse trig function.
Yes, inverse sine of what types of things?
Ratio
Ratios.
equals angles.
That's right.
I think we did this last year.
Yes, we did. And now we're going to cement it in the new construction project. Job creations. Angles. Yes. Okay. So inverse sine of a ratio equals an angle or angles. Okay, so that's basically the idea. So let's actually try one. We'll leave this up for a second, then you'll get more and more used to it. Let's do the cosine, or inverse cosine, of root 3 over 2.
Oh my lord.
All right, now, let's talk about what root 3 over 2 is. Is it an angle or a ratio?
Ratio.
It's a
Ratio. So this is the question. What is the angle whose cosine is root 3 over 2? That's the question.
Do we
You may, but let's actually go over here and let's understand it. Yeah, you can use a calculator as well. Let's understand it here. We're over here. You agree we're searching for the angle. We don't know the angle in this case.
Mm-hmm.
All right, where do I put the root 3? Where do I put the 2?
you put the root 3 on the bottom.
Opposite.
Yeah.
On the opposite.
Not opposite.
Root
on the
3 is on the bottom.
Oh, because it's cos.
Adjacent.
And 2 is on the
And what is this?
Then that
X.
is y.
Okay, this is a 30, 60, 90 triangle.
Oh.
Root 3. Oh, 2x. 2x.
No?
X.
Well, yes. What would x be in this case?
2. Wait,
It's not.
Root 3.
So here's the thing. If you ever blank out on 30, 60, 90 triangle, you could always solve for it. Y squared plus root 3 squared equals 2 squared, yes?
Yes.
That's the hypotenuse.
All right.
Y
and
squared plus 3
y
equals
squared
4.
plus 3 equals 4.
Oh, squared.
Y squared, thank you.
Yeah.
Y squared, get my cubes mixed.
Equals 1.
1.
So
Y
y
equals
is 1.
1. So this is your standard 30, 60, 90 triangle, okay? So if you ever blank on 30, 60, 90, no problem. You could always use Pythag to derive it. Derive so hard. Derive so hard! Now, what would this angle be?
60.
Well, 60 is going to be across
30.
the bigger side.
Or 30.
30.
This is 30,
because
yes.
it's across from the lowest.
Right. Root 3 is more than 1. Does that make sense?
Okay.
Root 3 is more than 1. So this would be 60 degrees. Or if we want to do it in radians. Let's do it in radians now.
Wait, why would that equal to 60?
Because the cosine of 60 is root 3 over 2. Do you agree we're doing inverse trig of a ratio? Inverse trig of a ratio equals the angle. Oh, you're right. It should be 30. That's what you're getting at, right? Thank you so much for that.
Anytime.
You were ahead of me. I thought you were asking about the whole concept. You're asking about my mistake. Thank you. Yes, it's 30 degrees. Good catch. Now let's do it in radians. Remind me, 0 radians.
Yes.
Yes.
Pi.
Pi over 2. Pi over -2. Or
Nope.
negative
Believe in you. You can do this.
pi over 4.
All right. Well, how many degrees is 360?
Oh,
yeah, all the way around.
it's wait,
So
which one?
360 is 2 pi, right?
Mm-hmm.
Yeah, and
that
And
helps?
it's
wait, which
pi
one? are you
is
asking for?
180.
Pi is 180. Cool.
Yeah. Sorry.
Oh,
Pi is 180. No
Yeah,
problem.
okay.
No problem. So now
wait,
here
is
we are.
360 up there?
Yeah, so 360 would be a full revolution. That's right.
Two.
And then what was this one?
That's
3 pi over 2.
They're resurrected. Okay. So now I want you to think it through. 30 degrees. 30 degrees. Is
Oh, that's annoying.
what?
Man.
What?
I could just see this problem forming. It's gonna.
Oh no, you're gonna like it. You're gonna like it.
Okay.
30 degrees is what fraction of 180 degrees?
One
Six.
not-
Six.
It is a sixth.
6.
So do you agree 30 degrees is 1/6 of 180 degrees?
Yes.
I do.
Therefore, what is 1/6 of pi?
1/6.
Say it.
Oh, sorry. I don't know why I said
You're
that.
1/6.
1/6 pi.
That's correct. So this we're gonna call pi over 6.
Miller. What?
Okay. Okay.
Mm-hmm.
Is 180 degrees pi?
Yes.
Yeah.
Do we want 1/6 of 180 to make 30?
Got
Yeah.
it. So you just divide.
Divided by
Got
6.
it. Got it.
Divided by 6. Bravo. Okay, good. That's good. Now, if you get that, you're going to roll from here. Okay, let's go inverse tangent root 3 over 3. Uh-huh. All right. Now, let's go here. Here's the angle we don't know.
Opposite over adjacent.
Opposite over adjacent. Yes. Yes. So now I'll do it this way. Root 3 over 3. Divide everything by root 3. Now let's see what happens.
Yeah. And then does the triangle then become
1
the
over. Now 3 divided by root 3. Let's do it. 3 divided by root 3. What do you multiply top and bottom by?
root 3?
Root 3 over root 3.
Mm-hmm.
Top becomes
Root 3. No, wait.
3
3
root 3.
3 root 3.
Yeah.
Good job. Bottom becomes
9. Root 9, which is 3.
3. Very good. These go. Becomes.
Root 3.
Yeah. So that's 1 over root 3. Instead of root 3 over 3, I'm going to write 1 over root 3. Sorry for the delay there.
It's all good.
1 over root 3. There it is.
All right.
2.
So that's 30.
So it's 30 again.
Wait.
Theta is 30.
Yeah. So this is 1 over root 3.
God, wait.
The angle that we're searching for is 30 degrees.
So
Got you.
instead it's 3 over root 3, not root 3 over 3.
Say it again.
So
The original problem, thank you for, let's make it very clear. This is root 3 over 3, which is really the same as 1 over root 3. So that's why I changed root 3 over 3 to 1 over root 3, so we can see 30, 60, 90 hiding inside.
okay.
So I just divided by, I did tan -1 over divided by root 3.
Yeah.
It equals 52.
Because you're in radian mode, go back to
Oh,
degrees.
oh.
Hit the
How do
mode.
you know when to go back and
Yeah.
forth?
Depends what the problem's asking for. It'll
Like
say
what
answer in
is a
radians.
typical problem for radians? What we're doing?
So the radian answer would be this.
Yeah.
Radian is an angle measure. What is 30 degrees again? It's on your paper.
When we get to
1
this,
over root 3. Oh, pi over 2. Pi over 6.
5 and 6. Question.
on like a formal exam, would
Yeah.
it tell you whether it wants the answer in radians
Yes,
or
it'll tell you.
degrees?
It'll tell you. Answer in radians or
It's the
answer-
same math for both, right?
Yes, it's the same math. It just depends on how you want to express the angle. If you want to express the angle in degrees, it'll be 30. In radians, pi over 6. Okay. Let's do more. So let's talk about the sine of the inverse sine of 1/3. Okay, now, 1/3 is what? An angle or a ratio?
ratio.
Ratio. Let's do the ratio.
How do you even check the time?
Here's the angle. We don't know what it is. Where does the 1 go? Where does the 3 go? If it's sine.
If it's
1
sine
goes on the right side.
Yes.
1.
and the 3
On the
goes
bottom.
on the bottom.
Hyp-
Oh, hypotenuse.
hypotenuse, right? Sine is opposite over hypotenuse. Very good. So now, that's the part of our triangle. So this here is the angle whose sine is 1/3. Right here.
Yes.
So now we want to take sine of this angle.
Uh-huh.
What is the sine of this angle?
It's going to be 60
What's the sine
of
of the
sine.
angle? You don't need it. Check it out. Inverse sine of 1/3 is the angle whose sine is 1/3. There it is.
So it's 3.
So now we want the sine. I'll bring down sine.
You're trying to find
So
the
is it just
inverse
sine
sine of 1/3?
It's not sine of 1/3. It's sine of this angle.
What is that
So it's
angle?
3. 'cause it's
What's the
left.
sine of this angle?
The sine of the
0.33.
If you recall, when you take sine of angles, it leads in what types of things?
ratio.
Very good. What's
Yes.
the sine of this angle?
3.
What's the sine of this
Yeah.
angle?
Wait. It's opposite over hypotenuse.
Very good. Which is
So
what
it's
over what?
1/3.
Bravo.
Wait, didn't you know that already then? So,
So
sine
what
of
is
negative
1/3?
1/3 is 1/3?
Sine of the inverse sine of 1/3
Is 1/3.
is 1/3.
Oh. Wait.
Well, that doesn't. Oh, this inverse sine of negative 1/3 is 1/3.
So this is called inverse sine. Inverse sine of 1/3 is an angle. I don't know what that angle is. Now we can get that angle. Are you in degree mode?
Yes.
You want to get, if you're in degree mode, do inverse sine of 1/3, please.
I just did it because 0.33.
You're in radian mode. Go back to degrees.
How do I
Go
do?
back to degrees.
Oh, can I just do 1 divided by 3?
Inverse sine of 1 divided by 3, yeah. How many degrees is that?
19.47.
19.47, 19.5. So this angle is 19.5 degrees, okay? So the inverse sine of 1/3 is the angle 19.5. Now it's asking, what's the sine of this angle? 1/3.
Oh.
All right.
In other words,
Goes forever. It's just 1/3.
do sine and inverse sine cancel each other?
Yes.
They are
Yeah.
inverse functions, they do.
So it even cancels the -1.
Yes,
Chill.
sine of inverse sine is canceled.
Yeah.
Okay.
All right, good. Now we'll leave it up. Let's do cotangent of inverse sine of 1/3. All right, now we're getting somewhere. The cotangent of inverse sine of 1/3. Now, inverse sine of 1/3 is this angle. Happens to be 19.5 degrees.
Uh-huh.
We don't care that it's 19.5 degrees. We don't care. But we just want the cotangent of this angle. So we go over here and we say, what's the cotangent of this angle? Again, sine inverse sine of 1/3 results in this angle.
Yes.
So we want the cotangent of this angle. Go over here.
19.5.
So it's,
Cotangent
it's
of
1 over 19.5.
19.5 is the angle measure. What's
Yeah.
the cotangent of the angle? It's good. You're getting closer to pay dirt, and when you get there, you're gonna.
Is it not 1 over 19.5?
It's not, because it's a ratio of sides.
Oh.
Please define cotangent again.
Cotangent is.
Let's do SOHCAHTOA. We'll leave it up. I've said that before. I believe it.
Oh,
We're really gonna
is
leave
it
it.
opposite over adjacent?
That's tangent.
Oh no. X.
Oh, it's hypotenuse over adjacent.
Do you agree that cotangent's the reciprocal of tangent?
Sorry, yeah.
So it's what over what?
Adjacent over opposite.
Adjacent over opposite. What's the adjacent side?
We don't know.
We don't know. Can we get it?
Oh,
Yes.
okay.
Using.
Apothem.
I know what you mean.
What's it
Oh,
called?
That's a P.
That's different.
But the sum
Pythagorean
squared.
theorem.
Pythagorean theorem.
Let's do it using Pythagorean theorem.
Let's do
A
it.
squared plus.
Before we do it, just be sure. This is saying cotangent of inverse sine of 1/3. Inverse sine of 1/3 is this angle, 19.5. It doesn't matter that it's 19.5. It's just basically this angle has a sine that's 1/3. Is it true that the sine of this angle is 1/3? Is that what this is? The sine of this angle is 1/3. Do you see
Yeah.
that?
Yes.
So the sine of this angle is 1/3. So this angle has a sine that's 1/3, whatever the angle is. Now, though, we want cotangent of the angle. And if you want cotangent of an angle, when you do cotangent of angles. And that results in what things?
Ratio.
Ratios. So now we're about to get the ratio of cotangent of this angle. Let's do it. 1 squared plus b squared equals 3 squared.
Okay.
1 plus b squared equals 9. B squared equals
2.8.
Simplify by square rooting both
4.
sides.
It's like 2 point.
Oh no, it's not. Wait.
Simplify root 8.
Is 2.82.
Simplify. So square root of 8 is 8 a perfect square?
No.
No. What's inside that is a perfect square?
Four.
4 times 2. Square root of 4 is
Two.
2 root 2. This
Ah.
goes down. 2 root 2. Now, tangent is opposite over adjacent. So cotangent would be the reciprocal adjacent over opposite, which
Uh-huh.
is what over what?
1
2 root
over.
2 over 1.
Yeah.
What? Yeah, 2 root 2 over 1.
2 root 2 over 1.
Mm-hmm.
Adjacent over opposite.
Oh, yes.
Thank you for focusing. I see that look on your face. 2 root 2 over 1. Don't need to write it. There it is.
Uh-huh.
Okay. They're going to get better. They're
Okay.
going to get better. All right, we'll keep this. You're going to see the pattern start to emerge.
Awesome.